We are up to question number 5 on the Unit 11 Test Review 1 worksheet. Number 5, for the equation a equals 1 over 4p, what is the value of a when p equals negative 1/2? All right, let's work this out. A is equal to 1 over 4p. Let's substitute the value of p, which is negative 1/2. Class, I'm going to draw this line in blue so you can see how important it is to keep the top and the bottom separated. Okay, let's change this 4 to a fraction 4 over 1 so we can see that we're actually going to multiply two fractions together. 4 times 1 is 4. 1 times 2 is 2, and we've got a negative times a positive. That's a negative 4 over 2. Now in this case, class, we could multiply the top and the bottom by the reciprocal, but because negative 4 over 2 is a whole number, if we check this out, we can see 4 divided by 2 is equal to 2. So because that's equal to 2, I can just simplify the bottom of this fraction. This is just 1 over negative 2, and we're actually done. You could write this as 1 over negative 2, you can write this as negative 1 over 2, or you could write this as negative 1/2. Every one of these is the same exact answer. Okay, so there's the letter B. Let's take a look. I'm sorry, there's letter A. Here's letter B. What if P is equal to 1? Alright, that means A is equal to 1 over 4p, which is 1 over 4 times 1. Again, I'm going to change these to blue so you can see I'm being very careful to keep the numerator and denominator separate. And that's just equal to, oops, I didn't need to be that in red. Let's put that in green. That is equal to 1 over 4. And we're actually done. That one's an easy one. And letter C, what if P is equal to 1/4? Alright, A equals 1 over 4p, which is equal to 1 over 4 times 1/4. Let's make sure we can see again that we're dividing this fraction up clearly so we don't get the numbers on top and bottom confused. Let's change this 4 to a 4 over 1, so we're multiplying two fractions. So this is equal to 1 over, and we've got 4 times 1 is 4, and 1 times 4 is 4. That's 4 over 4. That actually simplifies pretty nicely. We've got 1 over 1 because 4 over 4 is equal to 1. And 1 over 1 can just be written as, oops, let me get that the right color so I'm matching this correctly. 1 over 1 can be just written as positive 1. And there is our A value, positive 1. Alright, number 6. Write the standard equation of a circle with a center at 8, 0 and a radius of 8 inches. Alright, this is not a problem. We know that a standard equation of a circle is going to be x minus h. H is 8, so x minus h squared plus, now y minus k, class, k is 0, so we don't have to write subtracting or adding anything. We can just write y squared equal to, well, the value in, if you look at our vocabulary, the value in a standard form for a circle is r squared. If we know the radius is 8, that means this is going to be 8 squared or 64. Alright, next one. A center at negative 3, 4 and a radius of 5 inches. Alright, so we've got x minus negative 3. That's why this sign flips when you put it in the equation. It turns to positive. Plus y minus 4. We flip the sign of k. Since our value here is r squared, this is 5 squared, which is 25. If you need a reminder here, just as a note to yourself, r squared equals 8 squared equals 64. And for this one, we've got r squared, whoops, wrong color. You've got r squared equals 5 squared equals 25. That's where this number is coming from. All right, last one. C, a center at 7, 5 and a radius of square root of 10. All right. X minus 7, we flip the sign of h. Y minus 5, we flip the sign of k. And now we have equal. Let's go ahead and work this out. R squared is equal to the square root of 10 squared. And you know that a square root and a square undo each other. They cancel each other. And this just ends up being 10. So the value here is r squared, which is 10. All right, number 7. What is the radius? What is the radius of a circle? The radius of a circle with a center at 4, -2, and a point on the circle at 2, 3. Well, this is going to require us to do some graphing. Class, if I don't give you a graph, all you're finding is the distance between these 2 points. That's a center, and that's on the circle. The distance between these 2 points is a radius. You can use the distance formula, but since we have a graph, let's use it. 1, 2, 3, 4, -2. That is our center. And then 1, 2, 1, 2, 3. There is a point on the circle. Let's go ahead and draw a line segment between those two. And that line segment is our radius. And so now we can use Pythagorean theorem to find the radius. Make a right triangle. 1, 2, 3, 4, 5. This leg is 5. This leg is 2. And I know the radius is the length of the hypotenuse. That's r. So all I got to do is write 2 squared plus 5 squared equals radius squared. 4 plus 25 equals radius squared. 29 equals radius squared. Square root both sides and you end up with r is a square root of 29. That's not a perfect square, so there is our final radius. Square root of 29. All right, next one. What if the center is at 5, 2 and a point on the circle is at -1, 4? All right. So 5, 2, 1, 2, 3, 4, 5, 1, 2. There's our center. The point on the circle is -1, 1, 2, 3, 4. There is our point on the circle. Let's draw our radius of our circle. If we drew this circle, class, we'd actually have a circle that kind of goes around like here, way around off the graph. Same thing here. Here's our center, here's our radius, but it's not asking us to draw the circle. It's just asking us to find the radius. Okay, so we know that. Let's go ahead and change this into a right triangle. This is 2, 1, 2, 3, 4, 5, 6. This leg is 6. We know radius is the distance of the length of the hypotenuse. We've got 2 squared plus 6 squared equals radius squared. 4 plus 6 squared is 36 equals r squared. 4 plus 36 is 40 equals r squared. And we square root both sides and we find that r is the square root of 40. And again, it's not a perfect square. If I put that in my calculator, square root of 40, oops, that came out to be wrong. Square root of 40, and that has a decimal, so we're not going to change it to a whole number. Our radius here is the square root of 40. All right, we'll stop this video and we'll start up again on question number 8.